All right, day 3, we're going to look at the general addition rule. So probability is the likelihood of the event occurring. The probability is always be between 0 and 1. The probabilities of all possible outcomes have to add up to 1. The probability of an event not occurring, which is the complement, is 1 minus the probability the event does occur. So there's a typo. This is saying the probability of the complement is equal to 1, and see how it says minus? There's an equal sign here. It should be a minus sign. So it says, suppose you tear open the corner of a bag of M&Ms and pour the candy into your hand and observe the color. According to Mars Incorporated, the maker of M&Ms, the probability model is, and we have these different probabilities for the different colors. Explain why this is a valid probability model. So according to this, it says that all the probabilities have to add up to 1. So the first thing I should check is if I add up all of these numbers, do they add up to 1? So you're going to take your calculators, you're going to add them up, and make sure that they add up to 1. So we're going to say all the probabilities add up to 1. And we're going to say all the probabilities are between 0 and 1. Now it says find the probability that you do not get a blue M&M. So according to this rule, the probability that it's not blue would equal 1 minus the probability that it is blue. So the probability that it is blue is 0.24. So if we subtract, we're going to get 0.76. So that's my probability of it not getting a blue. And you could double check. You could also add up all the ones that aren't blue, and you should get the same number. Okay, example 2. An automobile dealer decides to select a month for its annual sale. Find the probability that it will be September or October. So when I have this or statement, I want to add the two probabilities together. So if we think about months out of the year, there's 12 of them. One month would be 1/12, and the other month would be 1/12. So I'm going to add them together. When I add fractions, I add the numerators. So I get 1/6, which simplifies to 0.167. Okay, you could use your calculator to add if you didn't know how to add fractions. That works too. Example 3, a community swimming pool. There are 2 managers, 8 lifeguards, 3 concession stand clerks, and 2 maintenance people. If a person is selected at random, find the probability that the person is either a lifeguard or a manager. So we're going to say the probability of a lifeguard plus the probability of the manager. So we need to figure out how many total people are there. We've got 2, 8, 3, and 2. So if I add up that total, I have 15 total people. So 15 is going to be in the bottom. How many of those are lifeguards? There's 8. And how many of those are managers? Is 2. So if I add those together, it's 10 out of 15, which simplifies to 2/3, which is 0.67. Alright, then we have mutually exclusive events. Mutually exclusive events are when events have no common outcomes. So if I can't have A and B happen, and so there's no overlap, there's no intersection. Remember, this symbol means intersection. They don't intersect at all. Okay, so it says determine whether these events are mutually exclusive. I roll a die, I get an even number, and I get a number less than 3. So if I roll a die, my possibilities are 2, 4, and 6. For evens, if this number is less than 3, it's a 1 and a 2. So 2 is on both lists, so they're not mutually exclusive. Because they overlap. Okay. B, select any high school course. The course is calculus and the course is English. So the course can't be both calculus and English. You can't take them at the same time with the same teacher. It can't be the same thing. They're two very different classes. So this is going to be mutually exclusive. Select a student from the classroom. The student has blonde hair and has blue eyes. So this is not mutually exclusive. Because the student could have blonde hair and blue eyes. It could be possible. If the events are mutually exclusive, we add the probabilities. That's really like what we did in example 2 and example 3. So that formula really goes with example 2 and example 3.